What's going on, everybody? Another statistics video here. This one is what is probability. So it's pretty much just a introduction to probability. Just basic probability is all it is. So let's go ahead and get started. So it says probability is a numerical measure between 0 and 1. So remember, whenever you find the probability of something, you're going to get an answer between 0 and 1. You can get 0 as an answer and you can get 1 as an answer, but it's going to be a number between those, or 0 or 1. If you get an answer larger than 1 or you get a negative answer, you did something wrong. All right, that describes the likelihood that an event will occur. Probabilities closer to 1 indicate that the event is more likely to occur. Probabilities closer to 0 indicate that the event is less likely to occur. And we'll write this, P of A, that's how it's read, denotes the probability of event A. If the probability of event A is equal to 1, event A is certain to occur. And if the probability of A is 0, event A is certain not to occur. A probability assignment based on equally likely outcomes uses the formula. So the probability of an event occurring is equal to number of outcomes favorable to the event divided by the total number of outcomes. So basically what this is, the probability of an event A is the number of successful outcomes divided by the number of possible outcomes. All right, so let's take a look at this example here. It says a random sample of 500 students at Hudson College were surveyed, and it was determined that 375 wear glasses or contact lenses. Estimate the probability that a Hudson College student selected at random wears corrective lenses. All right. So for this problem, we have the probability that the student needs corrective lenses. Okay, so we're looking for this probability here. That would be the number of successful outcomes, which is what? Well, that's 375 we know wear glasses from the sample. So that's 375 over the total number of students that we surveyed, which was 500 over 500. And that is equal to 0.75. So we could say that there is a 75% chance. This is a decimal. You can convert it to percentage. So there's a 75% chance. All right. So let's look at the next example. It says the Friends of the Library hosts a fundraising barbecue. George is on the cleanup committee. There are 4 members on the committee, and they draw lots to see who will clean the grills. Assuming that each member is equally likely to be drawn, what is the probability that George will be assigned the grill cleaning job? All right, so for this one, the probability that George is selected for the cleaning job he has to clean the grills. Well, what's the number of successful outcomes? Well, for it to be a success, we would have to choose George, and just George, because that's what it says. What's the probability that George will be assigned the grill cleaning job? So that's 1 divided by the total number that we can pick from, Well, it says there are 4 members on the committee, so that's the total number, 4, which that is equal to 0.25. All right. All right. So and that's really all that is. That's just the, just basic probability there. All right. All right. So let's look at this. We got some more examples to work, so just hang around. They're going to be a little more complicated than those two. All right, so now we've got law of large numbers. All right, so it says in the long run, as the sample size increases and increases, the relative frequencies of outcomes gets closer and closer to the theoretical or actual probability value. All right, so what does that mean? Okay, so for instance, let's just talk about flipping a coin. So if I flip a coin, what's the probability that it lands on heads? Okay, well, it's 50%, right? Because there's heads, there's tails. You got a 50% chance of it landing on heads. Now, if I took a coin and I flipped it 10 times, that would mean that 5 of those flips, it should land on heads. So I should get 5 heads, 5 tails. Now, is that going to happen? Probably not. Okay, it's probably not going to be 50% of the time that I get heads. But if I flip it 100 times, am I going to get 50 and 50, 50 heads, 50 tails? Probably not. But what about 1,000, 100,000, 1,000,000 times if I flip it? Is it going to be exactly half heads, half tails? Probably not. But what this law of large numbers is talking about is, say if I flip it 1,000,000 times, the number of times that I get heads, it's going to be closer to that 50% than, say, if I just flipped it 100 times. Okay? And that's what that means. All right, so let's see what else we got. It says a statistical experiment or statistical observation can be thought of as any random activity that results in a definite outcome. All right, so statistical experiment. So, it's just like flipping a coin. It's random how it's going to fall. Okay. An event is a collection of one or more outcomes of a statistical experiment or observation. A simple event is one particular outcome of a statistical experiment, and the set of all simple events constitutes the sample space of an experiment. All right, so an event, that's like, let's say that you roll a die, okay, a single die. You got dice, 2 dice, 1 die. So what are all the possible outcomes that I could get? Well, that would be like the sample space. All right. So the sample space for rolling a single die would be 1, 2, 3, 4, 5, and 6. That's my sample space. That's all the possible outcomes. Now, let's look at an event or a simple event. So, what would be the event of rolling an even number? Okay, and we'll call this E, this event E. E is the event of rolling an even number. Well, E would be 2, 4, 6. That's an event. Okay, so an event, it's like a specific something that they tell you, like, okay, what would be the event of me rolling a number larger than 4? Well, that would just be the event that would contain 5, 6. Okay, so that's an event. A sample space is all the possible outcomes. Okay, all right. So now let's look at this example here. It says human eye color is controlled by a single pair of genes, one from the father and one from the mother, called a genotype. Brown eye color, B, is dominant over blue eye color, L. Therefore, in a genotype BL consisting of one brown gene, B, and one blue gene, L, the brown gene dominates. A person with BL genotype has brown eyes. If both parents have brown eyes and have genotype BL, what is the probability that their child will have blue eyes? What is the probability the child will have brown eyes? All right, so they don't, in this problem, they don't tell us like they did in the first two examples that we worked. They don't tell us how many successful outcomes there are, how many possible outcomes there are. See, in these two previous examples, they gave us the number of possible outcomes, which is 500, and they gave us the 375, which was the number of successful outcomes. And in this one, they didn't come out and say it like they did in this problem, but we know the number of possible outcomes. That was 4 because there's 4 people on the committee. And then they said, what is the probability that George has to clean the grill? So we know the successful outcomes is 1, the possible outcomes is 4. So that was pretty easy to determine. But in this problem, they don't really tell us that. So we have to kind of write out we have to get what the sample space is. All right. So for this one, we're going to need to kind of draw this out. That's a L there. And then we have the mother here. All right. And she's going to have BL. All right. Let me make that line a little shorter. All right. So this, if we match this, we've got B, B. Here we have BL, BL. Here we have BL. See where they intersect, BL. And then this one, LL. All right. So what do they want to know? They want to know the probability of blue eyes. What is the probability that their child will have blue eyes? Well, the only way that they're going to have blue eyes is if they have the LL. Okay? See, this would be brown eyes, brown eyes, brown eyes, and this would be the blue eyes. And I guess, technically, since we're doing B, 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 L, this one, I guess, since we're putting the fathers first, I guess it really doesn't matter, but let's just go ahead and do this. Write it LB. Okay, we're going to do B, 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 L, L, B, and LL. All right. And so what's the number of successful outcomes? Well, there's 1, right? This is the only one that's going to give blue eyes. So that would be 1 over the number of possible outcomes. Well, how many possible outcomes are there? There's 1, 2, 3, 4. And so that would be 0.25. And look, if you wanted to, You could come over here and write the sample space as B, 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 L, L, B, and L, L. That would be your sample space. These are all the possible outcomes right here. And that would be your sample space. And then the next question, what's the probability of brown eyes? Okay, well, that's the number of successful outcomes. And look at this. We have the sample space written. Which ones are going to give us brown eyes? This one, and this one. 1, 2, 3. So there's 3 successful outcomes over 1, 2, 3, 4 possible outcomes. So this would be 75% chance. So the probability that they will have blue eyes is 25%, and the probability they will have brown eyes is 75%. Okay, so sometimes it's not just going to come out and tell you, oh, here's how many possible outcomes, here's how many successful outcomes. You may have to draw it up and, write it out like we did here. That is a possibility. All right, so let's look at this one. It says a professor is making up a final exam for a course in literature. He wants the last 3 questions to be of the true-false type. To guarantee that the answers do not follow his favorite patterns, he lists all possible true-false combinations for the 3 questions on slips of paper and then picks one at random from a hat. What is the probability that all 3 items will be false? What is the probability that exactly 2 items will be true? All right, so here's one where we need to write out the sample space. Okay, now this one, writing out this sample space can be it's not difficult, but it can be a little more difficult than writing out the sample space for this one. You've got to make sure that you get all the possibilities. And I'm not going to do it in this video because there's another video after this one that goes into tree diagrams. And that would probably be the easiest way to get the sample space, is doing a tree diagram. But I'm going to show you that in the next video. But basically what we need to do, so we can get all 3 questions to be true, right? All right, so all 3 questions can be true. And then we can have false, true, 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 false, true, and true, true, false. So you see what I did there? I said, okay, all of them can be true. And then I picked one question could be false. So I made it the first question, and then the second question, and then the third question to be false. All right. And then we can have it where we have false, false, true. Okay, so one of them can be true, and then I have false, true, false, true, false, false, and then I have it where all of them can be false. And this is actually, let me see if I can write that a little better. This is actually your sample space here. We've got 1, 2, 3, 4, 5, 6, 7, 8 possible outcomes. Okay, and that's all the possible outcomes. And watch the next video, and we'll do something similar to this, to where we use a tree diagram to get all of these options. But what I have here is I've written out all the possible scenarios for the answers on the true false question. And so what do we want to know? What is the probability that all 3 items will be false? Okay, so probability all are false. Okay, so this is one of the benefits of writing out the sample space. So I want all three answers to be false. And you can see this is the only one where all three answers are false. So there's only one option there. And that's divided by the number of possible outcomes, which is 8. So that's 0.125. So it's like a 12.5% chance. And then the next thing they say, what is the probability that exactly 2 items will be true? So exactly 2 are true. All right. So all we're going to do here, we're going to go through and see which ones have 2 items that are true. Well, that would be this one, and this one, and that's all of them. So there's 1, 2, 3 of them. So that's 3 over the number of possible, which is 0.375. So about 37.5% chance that exactly 2 of them will be true. Okay. All right, moving right along. So it says the sum of probabilities of all simple events in a sample space must equal 1. All right, so that makes sense, because if you take all the probabilities and you add them up, that has to equal 1. All right, so that where that's going to help us is with this next part here. It says the complement of event A is the event that A does not occur, and it's denoted this A with the C up here. Now, I don't know the textbook I'm using. This is the way it does complement. You may see complement written like this in some textbooks, and there may be other symbols. Okay. Some textbooks may use different symbols to represent the complement. The book I'm using uses this C up here. Some, I know you'll see this as a complement also, this little mark here. So if we take the probability of A plus the probability of A complement, that should equal 1. Okay. And then it says here the probability event A does not occur is the probability that the complement of A, which is equal to 1 minus the probability of A. All right, so let's do this example and I'll explain what that means while we're working this example. All right, so the probability that a college student who has not received a flu shot will get the flu is 0.45. What is the probability that a college student will not get the flu if the student has not had the flu shot? So that's the opposite of what it's giving you here. The probability that a college student has not received the flu shot will get the flu is 0.45. So if they have not received the flu shot, the probability of them getting the flu is 0.45. So what's the probability of them not getting the flu? Well, that is the probability of not, I'm just going to put not flu, not getting the flu. Well, if the probability of them getting the flu is 0.45, then the probability of them not getting the flu is 1 minus 0.45, which is 0.55. Okay? And that's all that is. Now, you know, they gave us the probability that they got the flu. Well, we don't have any other information to go on them not getting the flu. So we don't have the number of successful outcomes. We don't have the number of possible outcomes. They just give us the probability. And then they're asking just the complete opposite, the complement of what they're giving us here. They're asking us the opposite of that. So it's just 1 minus that. Okay? Because remember, it says the probability of A plus the probability of A complement equals 1. Okay. So look, if you take this, let's take this, and if you, let me show you. If you take the probability of A plus the probability of A complement equals 1, and we subtract the probability of A to both sides, that's the probability of A complement is equal to 1 minus the probability of A. See that? And it's just 1 minus the probability of A to find the probability of the complement. And that is the last example. We are done with this video. So I've got more probability videos. This book breaks probability down, I think, into 3 sections. So we'll have 3 videos on it. So we'll get into some more compound events, stuff like that, a little more difficult stuff in the next couple of videos. So I hope the video helped. Check out my other videos. Give me a like, share, subscribe, comment. Thanks for watching. I'll see y'all in the next one. Later.